Hello and welcome to BAL's Tiling Solutions for Leisure Centres CPD. My name's Allan, Garland and I'm the Specifications Manager for the Southwest. As with our previous CPDs in this series, this seminar is recorded, so unfortunately we can't take any questions during the presentation. So please either give me a call or send me an email using the details on this slide if you do have any questions or would like to discuss a live project. BAL has a proud history. We were founded in 1962 by the tile manufacturers that constituted the British Ceramic Tile Council. As tiles materials were changing and there were no specific products or guidance for fitting tiles, the industry was starting to experience installation failures. To ensure tiles could be used successfully and grow as an industry in the UK, the council formed a specialist materials company to develop high quality products for tiling installations and provide a comprehensive technical advisory service for the industry. BAL was formed for the industry, by the industry, and it's a value intrinsic to all we do today. We have a number of different teams here at BAL who will be able to aid you at each different stage of the project. The specification team, for example, can deliver any of our 8 RIBA-approved CPDs in practice and also help advise which products to specify. We could even write that M40 or M20 specification for you. Our task team, or technical advisory service team, who are based at our head office in Stoke, are on hand during office hours for market leading technical advice. Now this is all backed up by our technical and training teams who are available for on-site technical advice, as well as systems training for contractors who may have not used the system previously, and things like moisture tests on newly laid screeds. So in today's seminar we're going to go through some general design considerations, correct selection of materials, including adhesives and grouts, then common scenarios such as swimming pools and changing rooms, wet rooms, and then looking at some key installations and a quick summary. General design considerations. Successfully specifying and installing a tiled wall or floor relies on identifying all of the key elements of the installation. These can include substrate, prep, environment and tile type. We'll discuss each of these in more detail during the next few slides. When choosing a substrate, we must consider the weight restrictions and load considerations of that substrate, the surface regularity of the substrate when installing rigid finishes like tiles and natural stone, and also the drying times of those substrates. How long do we have to wait before we can tile to them? Adequate pre-preparation of the substrate is of course important. The dimensional accuracy of the background or base is crucial. BS 5385 tells us that the tolerance for finished floor levels is SR1. Now this is a surface regularity of 3 mm under a 2 metre straight edge. When we check the floor with a 2 metre straight edge with 3 mm feet at each end, any gap underneath the straight edge between the points of contact should not exceed 6 mm and there should not be contact between the floor and the straight edge. If the floor surface regularity is not SR1, it should be corrected prior to tiling commencing on site. This can be done with a smoothing or levelling compound. The recommended drying time for construction substrates is also an essential element for ensuring the success and longevity of the tile installation. The specific requirements are laid down in BS 5385 parts 1 to 5. These are the codes of practice for ceramic and natural stone wall and floor tiling. Here are some examples of new substrates drying times. Let's take sand and cement render for example, which is 2 weeks. Now this can be sped up by using a proprietary pre-blended rapid setting and drying render. That can be as little as 2 hours. Sand and cement render in swimming pool tank, that can take 3 weeks. Sand and cement screeds normally take 3 weeks, but again, like a render, these can be sped up as quick as 4 hours if you use a proprietary rapid setting or drying cement instead of Portland cement. Gypsum plaster is 4 weeks. Concrete walls and floors are 6 weeks, and new block and brickwork is 6 weeks. If the substrate to be tiled is not flat and even, any undulations will be reflected in the tile finish. BS 5385-3 2014 recommends that surface regularity of SR1 when fixing tiles using a tile adhesive. No gap underneath a 2 metre straight edge greater than 3 mm when placed anywhere on the floor. If we talk about tanking, looking at a wet room or a shower, we need to protect the substrate. This is for a number of different things. It can protect the integrity of the building fabric and also protect the room from mould and unwanted smells. Priming. If the surface of the substrate is porous, then this could affect the success of the adhesion of the tiles, so it's always worth priming those substrates. Uncoupling. Now this may be required because of the variation in lateral movement between the tile and the substrates. Check the substrates for the ability to crack. The adhesive and grout must be capable of being exposed to dry and wet conditions. Also, we need to make sure it can withstand changes due to thermal effects, and also provide a tiled area capable of withstanding extremely harsh surface conditions. The tile, adhesive and grout must be water and frost resistant. The grout, for example, could also need to be abrasion resistant. So if we have any attrition in the pool, let's say we've got a wave pool or a lazy river, for example. We also need to make sure that these elements can withstand exposure to cleaning chemicals and chemicals used in the swimming pools, like in the swimming pool water. There are now thousands of different designs of tiles to choose from. When installing tiles, if they're installed correctly using the right types of materials and specifications, they can be easy to install, hard-wearing and durable. We put a 25-year guarantee on all of our specifications, for example. This allows us to give you the confidence that if they're installed correctly to the right specification, they will be hard-wearing, durable, easy to maintain, and have lower life costs than some other finishes. The correct selection of a suitable tile is imperative for the long-term success of a project. BS EN 14411 is the standard regarding ceramic tiles, their definitions, classifications, characteristics and markings. In simple terms, ceramic tiles can either have a porous body, approximately 10% water absorption, a vitrified body, which is 3 to 6% water absorption. Lower porosity tiles tend to have between 0.5 and 3%, and then we go on to fully vitrified bodies, which is a porcelain tile, and that has a very low porosity of up to 5%, but not exceeding, up to 0.5%. BS EN 12057 is the standard for natural stone. A natural stone is considered a tile when it is no larger than 610 mil on one length, and also is no thicker than 12 mil. Anything above that is considered a slab, and these are normally covered in BS EN 12058. BS 5385 Part 4, the Code for Practice for Tiling and Mosaics in Specific Conditions, offers further guidance on the suitability of tiles for floor tiling in specific conditions. So for use in domestic or commercial showers, swimming pools, changing rooms and high humidity areas, etc. We must make sure that the tile is suitable for the environment into which it is to be exposed. In addition, where heavy loads are likely to be imposed, particularly when considering hard rim wheeled vehicles, the strength of the floor could be improved by the use of a dense body, so a vitrified and thicker tile. Further advice should be sought from the tile manufacturer if you're looking to specify that brand. The health and safety law requires that floors must not be slippery, so they don't put any person's safety at risk. One method for testing slip resistance of ceramic tiles is a pendulum test to BS 7976. This device uses a swinging arm to simulate the slipping foot, and it can be used wet, dry or with specific contaminants. Research has shown that the pendulum test is a reliable and accurate way of measuring slip resistance both in dry and wet conditions. For this reason, the HSE have adopted this particular test method. In general terms, the slip potential is classed as below 25 is dangerous or high potential for slipping, 25 to 35 is marginal or moderate potential for slipping, 35 to 65 is safe or low potential for slipping, and 65 plus is extremely low potential for slipping. Ceramic floor tiles are not slippery when clean and dry. The way we increase the slip resistance of a ceramic tile is create a rougher surface. Now, the rougher the surface, the more difficult that product will be to clean. Now, this can be cleaned using mechanical means and things like that, but sometimes it's not suitable. So when at the specification stage, it's worth considering the inclusion of a cleaning regime, and this might be aided by discussing the cleaning regime with the tile manufacturer. There are different types of ramp tests employed in the industry. The DIN, which is a German test, uses oil as lubricant, and the test subject wears boots with rubber heavily profiled soles. The higher the R rating, the greater the slip resistance. R9 considered the minimum value for use of a tile in a public area. The UK HSL has two tests, one using plain water as a lubricant and normal type shoes, with 4S rubber soles and heels. Test 2 is again using water, but under barefoot conditions. The CEN, which is European standard, uses a barefoot ramp test. However, a wetting agent is put into the water. This table is a guide to the R ratings as determined by the DIN ramp test and the environment or work areas to which the particular value is recommended. It's also wise to note that as the R rating increases, so does the roughness of the tile. First and foremost, safety in use. This should take into account the floor tile slip resistance both in dry and wet conditions, the solidity of the tile finish, i.e. are the tiles fully bedded in the correct tile adhesive. Now, we need to look at the correct cleaning methods. If we specify an incorrect cleaning method, this could hinder the tile slip resistance in the long term. Movement in the substrate. When we look at the movement in the substrate, we need to make sure we don't have excessive deflection, thermal movement, or drying shrinkage. Also, the correct placement of movement joints could aid with the reduction of cracking in the tile finish. Environmental factors. As we discussed on previous slides, are we going to have a heavy traffic load in, and what's this going to do to the tiled finish? Also, are we tiling in an area like a workshop where we have the possibility of heavy objects being dropped? This could cause major impact damage. We're now going to move on to looking at tile adhesives and grouts. The correct selection of materials. Tile adhesive classification and standards. We have three categories of tile adhesives: cement-based, dispersion and reaction resin. Cement-based normally comes in a bag of powder and is mixed up on site. Dispersion comes in a tub which is water-based and ready mixed, ready for use. A reaction resin is normally a 2 or 3 part product with a resin and a hardener. Moving on to the classifications, we have 1, which is a normal adhesive, 2, which is an improved adhesive. This meets the requirements for additional characteristics. Then we have a lettered system. So F is a fast setting adhesive, normally cementitious only, and that achieves 0.5 newtons per millimetre squared within 6 hours. T, which is non-slip, that's normally used on walls, and then E, which is an extended open time, which is over 30 minutes. This is for cementitious and dispersion adhesives only. The first three are not tested for in accordance with the EN 12004 requirements, but are important to the end user and assist in providing an adhesive which is easy to mix and apply with a good working time. This allows for adjustment of pre-bonded tiles within a given time. BS EN 12004-2 has a test to measure for transverse deformation of tile adhesives. This gives us S1, which is deformable, and S2, which is highly deformable. Grout classifications and standards. In this section we have cementitious and reaction resin. Cementitious is normally, again, a bag of powder, and reaction resin is normally a 2 or 3 part product which you mix together, which is either a resin, a hardener and a colour, or a resin with a hardener and colour mixed together. The cementitious grout has 2 categories: 1, which is a basic grout, 2, which is an improved or polymer modified grout. The lettering system gives us W on the cementitious side, which is reduced water absorption, and A, which is high abrasion resistance. The main difference between a cementitious grout and a reaction resin grout is that reaction resin grouts are more often waterproof. So on to tiling in wet and damp environments. It's likely that tiling will be carried out within a leisure installation, which then might be subjected to different environmental conditions like the ones listed on this slide. One of the main reasons for utilising ceramic tiles, for example in pool halls and shower changing rooms, is their ease of cleaning and maintenance. When properly installed and maintained and regularly cleaned, tiles will provide a long-lasting, durable and trouble-free wall or floor finish. Choosing an appropriate cleaning regime is also important. The Tile Association offer further guidance on this in their document, The Cleaning of Ceramic Tiles. So in this section we're going to look at different types of swimming pools. Fundamentally, a swimming pool is a water retaining structure. There are many different types of swimming pools. Some of the more common pool types include a competition pool. Now these are rectangular shaped, either 25 or 50 metres long and at least 1.35 metres deep. Competition pools are generally indoors and heated to enable their use all year round, and tiling to the pool tanks with facilities for competition swimming or water games, etc., are defined by ASA of FINA requirements to ensure that there are no cut tile pieces and require racing lane markers and timing pads. An Olympic pool is a pool that meets FINA's additional standards for the Olympic Games and for World Championship events. It must be 50 metres in length by 25 metres wide, divided into 8 lanes of 2.5 metres each, and 2 areas of 2.5 metres each side of the pool. The water must be kept at 25 to 28 degrees C, and depth must be at least 2 metres. Freeboard pools are the most common, and where the water level is lower than the top of the pool surface, is removed via a skimmer built into the wall. Free-form pools are designed to have an irregular shape, often curves and graceful lines. These are used for leisure or private swimming pools and can often have wave-making facilities, rapids or lazy rivers for example, flumes even. Hydrotherapy pools are used in hospitals and rehabilitation centres. They are designed for physiotherapy and treatment or medical conditions. The water temperature is higher than conventional pools, ideally maintained between 34 and 35 degrees C. Temperature, pressure and water movement is also controlled. Deck level pools have a water line which is level with the pool surround and transfer channel connected to the balance tank. On this slide we're showing you a table which details the drying times of constructional backgrounds when used in a pool tank. Normally, under no circumstances would we reduce these intervals. A longer period is sometimes necessary in wet weather or poor drying conditions, but by replacing Portland cement in screeds and renders for a rapid setting cement or a pre-blended product, we can reduce these, sometimes down to 2 hours for a render and 24 hours for a screed. It's always advisable to check with the manufacturer of those products prior to specifying them. Any joints in the structural shell designed to accommodate movement should be carried through to the face of the tiling. Movement joints should be incorporated in the pool lining, around the perimeter at junctions at the bottom of the sides, vertical corners and at any changes in plane in the bottom of the pool. It's advisable to insert additional movement joints down the pool sides and across the bottom in a continuous loop at 6 metre intervals or less to suit design considerations. Movement joints should also be inserted at the junction of the pool tank and the promenade deck. The Tile Association recommendations are for a water calcium hardness of at least 250 mg a litre or bicarbonate alkalinity of at least 80 mg per litre. Both of these are expressed as CaCO3. Sulfate levels should typically not exceed 300 mg per litre. So this means for grout, if we've got hard water which is over 250 mg per litre, we need to use a modified cement-based grout which is a CG2 grout. For soft water, which is less than 250 mg per litre, it's advisable to use an epoxy-based grout or an RG grout. Pools should be filled and emptied slowly in order to minimise stresses due to loading and thermal changes. The maximum filling or emptying rate should be controlled so that the water level rises or falls around 750 millimetres every 24 hours. The recommended heating rate for a pool water is 0.25 degrees per hour. This is in order to minimise the effects of thermal movement during the heating process. Moving on to wet rooms. In a wet room, the walk-in shower area is usually level with the surrounding floor but with a slight slope to the drain which is fitted directly into the floor. They're particularly useful for someone in a wheelchair with level entry to the shower area. And a wet room is more versatile than the conventional shower tray enclosure, and this gives us more options in the bathroom design. The concept allows the showering area to blend naturally with the rest of the room. Some types of underfloor heating systems can be used within wet rooms. Without proper waterproofing protection, water penetration and ingress behind the tiled finish can cause serious damage to wet room installations in the long term. BS 5385 Part 4 states that the use of ceramic tiles together with an impervious grout and adhesive are not a substitute for a tanked installation. The effects of water damage are well known and well documented. Therefore, incorporation of a suitable waterproofing membrane is a prerequisite for a wet room installation, either within the building structures or ideally on the substrate prior to tiling, Surface tanking membranes are ideal as they are able to prevent water from tracking through a screed, for example, into other areas. In a wet room, waterproofing should be specified on both walls and floors. There are two main types of liquid applied tanking membranes compatible for use with ceramic tiling installations. Single part membranes, such as a single component liquid applied water impermeable product like an aqueous polymer dispersion based coating, and a two component membrane. These can be a cementum polymer dispersion based or based on epoxy and polyurethane resins. We always use a scrim tape to reinforce the membrane in areas subject to movement, areas like pipe penetration, drainage outlets and channels, junctions between different bases and background substrates. Also, it can be used to bridge any cracks within the base of the background and used in internal and external corners and partitions within boards if boards are being used. So, considerations: disability awareness. We need to look at slip resistance of the floor, and this should give a firm foothold and good wheel grip in any dry and wet conditions. We should also look at colour contrast for increased visibility for fixtures like grab rails, skirtings and seatings. BS 5385 advises that falls in the floor should be a minimum of 1 to 80 and a maximum of 1 to 35. Anything steeper than 1 to 35 may be inconvenient and may also be dangerous. The rate at which the water drains away from the floor should be greater than the flow rate of the water produced by the shower head. Incorporation of a lower flange enables the waterproof tanking system to be dressed into the gully and form a watertight seal. The waterproof tanking system should be suitable to both receive a tiled finish and be compatible with the type of drainage system selected. An efficient removal of water vapour and the adequate ventilation and dehumidification helps in reducing the risk of mould growth. Now let's take a look at changing rooms. There are a few key points to consider when it comes to specifying tiling in wet room areas. What's the substrate? What are we tiling to? Is there underfloor heating, or is there underfloor heating to be installed? Requirements for slip resistance for safety reasons. That could change the type of grout we specify, for example. Cleanliness and hygiene for ongoing maintenance. Now, this should be specified in the installation stage to solve any issues going forward. The effects of thermal expansion and contraction need to be accommodated and controlled. There are 4 important factors which can influence the success of any tiled installation over heated floors. These need to be considered and accommodated within any tiling specification. We must consider the effects of differing expansion and contraction rates for the floor type versus the substrate. They will move or expand and contract at different rates, and this could cause problems. We need to minimise the thermal and shrinkage movement stresses. It's important to commission the underfloor heating prior to the commencement of tiling and also post the completion of tiling. The correct placement of movement joints for the purpose of controlling stresses both within the tiling and the substrate. And we also need to choose the right adhesives and grouts. Using a flexible polymer modified adhesive and grout will also help with movement stresses. Safety in use is the utmost concern in commercial wet areas like changing rooms. Choosing tiles with the appropriate slip resistance is important. As a rule of thumb, the higher the slip resistance, the rougher the tile surface, and remember to refer to industry test standards when selecting the right tiles. We have the pendulum test to BS 7976 and the German ramp test, which is DIN 51097, both of these for wet areas. It's advisable to include the clean and maintenance regime at the specification and design stage. This will influence the choice of tiles and their slip resistance, and also the grouts and sealants for movement joints. We would avoid the use of aggressive chemicals and products with a high acidic or highly alkaline nature. These agents can attack cement-based products, causing damage in the long term. Table 2 of British Standards BS 5385 Part 3 has useful information regarding resistance to intermittent contact with various liquids and characteristics for different grout types. Epoxy grouts are in general chemically resistant to splash contact for a range of dilute acids, alkaline and solvents. So it might be worthwhile swapping this out for a cement-based grout if you do have any products that might cause damage to cement-based products. The TTA technical document on cleaning and maintenance of wall and floor tiles offers additional advice with regards to the cleaning of glazed and unglazed ceramic tiles and also natural stone. So now we'd like to talk you through a couple of case studies. Huddersfield Leisure Centre is a 12,500 square metre, £36 million leisure centre development in the heart of West Yorkshire. It's a good example of differing environments and challenges that we had to consider. It features a range of top sporting and leisure facilities, including a 25-metre competition pool, 20-metre training pool with a movable floor, and a family leisure pool with interactive water features, water flume and sidewinder. The new centre was designed to meet the client's brief for a multi-purpose sporting and leisure facility for the local community, which complements the existing street pattern and contributes to the regeneration of the town and surrounding region. The project featured more than 10,000 square metres of tiling in the main changing rooms, upstairs changing rooms, pool surround, leisure pool and main swimming pools. This calls for numerous preparation products such as screeds, renders, primers and bonders, as well as a number of different tile adhesives that were utilised based on the environment, substrate, tile type and installation need. The stunning £45 million redevelopment of Tate Britain was an award-winning example of tiling in leisure. The transformation included the Millbank project, creating new spaces within the national home to 500 years of British art. Stonework specialists completed 2 packages in the Grade 2 listed building's southeastern quadrant on staircases and flooring, involving both new build and restoration work. As a major addition to the museum's former layout, a large opening through the floor of the main entrance rotunda allowed a new staircase to be inserted. A further 2,000 metres squared of flooring included a stunning geometric design that extends through the lower level of the museum, the canteen, public areas and lower rotunda. The flooring at the top of the grand staircase has a complicated fleur-de-lis pattern that echoes the design of the staircase balustrade. In addition, 500 square metres of agglomerate skirting, dados and reveals were installed. A further 800 square metres of terrazzo flooring on the principal and upper levels and the marble mosaic flooring in the entrance hall were also cleaned and repaired. Specialist product selection was key to use across the range of different tile types and to ensure ease of installation and the highest quality results of aesthetics to last a lifetime. So thank you for your time, and if you do have any questions or would like to discuss any projects, please do get in touch using the information at the beginning of the presentation.